Hello, and welcome to the AI HTL Design Phase 3 demo. This tutorial will teach you how to evaluate and optimize your design's area efficiency and power consumption, highlighting their importance in chip design and providing actionable tips to improve hardware usage and energy efficiency. Please keep in mind that the code shown in this presentation, like all code generated in ChatGPT, may have bugs or compatibility issues with the rest of your design modules. Generating functional code from ChatGPT is an iterative process and takes time. This demo is meant to give you a starting point for optimizing your design. Copying the code or prompts in this presentation is not guaranteed to give you a functional design. In order to get the metrics required for optimization, you first must run implementation of your design in Vivado. In order to run implementation, you must add and properly configure a constraint file for your device. A constraint file is a file used to tell Vivado which aspects of your design map to which physical inputs or outputs on the board. You can download the constraint file from the description of this video. To upload the constraint file, simply click Add Sources, Add Constraint, and upload the file. We will now demonstrate working with the constraint file. After uploading the constraint file, you will see the Basys 3 master.xdc file under constraints in your source tree. After opening, you can see a variety of different pins, LEDs, buttons, and switches, as well as any other physical features the Basys 3 board may have. To get the implementation working properly, you must uncomment the features you are using and change the final variable in the line to the correct variable name outputted from your top level. If you need help with this process, please reach out to the mentors, and we would be happy to assist you. We will now run implementation for our design. In the bottom left, if we click Run Implementation, we will see in the top right a spinning icon. This indicates that implementation is running. We will cancel ours because implementation can take a long time. However, you should let yours run until the very end. Now, if we go to Window and press Project Summary, a window will appear that showcases all relevant project metrics, including power and utilization. These will be very important for optimizing your designs. Let's talk power. Power consumption in circuit design is critical for ensuring efficiency, thermal stability, and compatibility with system power supplies. Luckily, Vivado automatically gives metrics on power after running implementation. On the bottom right, you can see an example of the power statistics for a Vivado project. We will now optimize our digital watch design's power usage by prompting ChatGPT for code optimizations. Here, we ask ChatGPT how we could potentially lower the power consumption for the code we have given it. It recommends implementing clock gating, reducing our toggle rates, minimizing bit transitions, and reducing switching activity. It then generates new optimized code that we can use in our project. After inserting this code into our project, we can see that our total power consumption has gone from 0.109 watts to 0.092 watts, meaning that we have saved approximately 0.017 watts through optimization. AI tools like ChatGPT are invaluable for optimization, but analyzing Vivado's power usage report helps identify high power components. This can help cut down the time needed for optimization by giving you a clear idea of what is taking a lot of power in your system, allowing you to focus on improving that specific part of your design. Area efficiency measures hardware resource usage in circuit designs, and Vivado's utilization statistics helps identify where we can minimize logic usage while retaining the required functionality. Using this, we can clearly see what areas of our design need improvement and choose what to optimize more effectively. We will now optimize our digital watch design's area efficiency by prompting ChatGPT for code optimizations. Here, we ask ChatGPT how we could potentially improve our area efficiency for the code we have given it. It recommends implementing counter merging, logic optimization, and state encoding. It then generates new optimized code that we can use in our project, as well as describing all changes it has made to our original code. After inserting this code into our project, we can see that our original utilization has about 12% of available I/O logic used. Meanwhile, our optimized code only uses approximately 9% of I/O logic, meaning we have improved by about 3% I/O resource utilization from our optimization. Utilization statistic tables in Vivado reveal which resources are most heavily used and therefore take up the most area. Knowing what aspects of your design have the most room for improvement enables targeted optimizations, saving lots of time and energy in the long run. ChatGPT can optimize code for area efficiency and power usage by refining registers and improving basic logic. However, it is important to remember that even ChatGPT has its limits. Make sure to keep your prompting within a reasonable scope to avoid any potential mistakes. Thank you for watching the AI HDL Design Phase 3 demo. As you continue working on your project, remember that optimization is a gradual process. Small, consistent improvements can add up to significant results over time. If you ever feel unsure about the next steps or need guidance, don't hesitate to reach out to your mentors for advice and support. Want to learn more? We've got you covered. Watch these videos to dive deeper into how smartphone chips are made and how Verilog works. These will help you on your journey to mastering hardware design. We would like to give a big thanks to all of our sponsors for supporting the AI HDL competition.